All right, Georgios, great to have you. I'm here to ask you a couple questions about Noir. So first, I wanted to ask you, what is the coolest programmable cryptography application you've seen recently using Noir or otherwise?
Yeah, for me, the most exciting use cases, well, zooming out, crypto is great because it allows transfer of value on the web, like the internet allowed for transfer of information. But crypto becomes so much more useful if you can do two things. A, private transfer of value. There's no world where you can do global scale crypto without privacy involved in it. And attestations, secondly, attestations to either real world information, for example, credentials. Say you have a passport, an identity card, and you want to use that to do on-chain identity. And two, web proofs, like things where I can show to you that I'm logged into my JP Morgan account and I have at least this much value logged in. So to me, I think privacy is, of course, like something that's like very well discussed. But to me, the most exciting use cases come around the real world attestations. So one very clear use case and application that I care about a lot is the ZK passport angle, because it lets me solve two things. I can do A, account recovery if I've lost access to my wallet or to any other kind of credential. Two, I can implement Sybil resistance systems with it. For example, I can say that only a user that has scanned the passport can access this app, and I can use this to geo-block users, or I can use this to target them. And the third thing I can do with such technologies, I can do selective information disclosure about private information, which means that I can show to you that I'm, say, above 21 without giving you full access to my information. So all of these things that take real-world information and let you make cryptographic attestations to them are really interesting. And to me, I think the ZK passport or the ZK identity use case is just so crisp and like obvious to people.
So this all seems like it fits into maybe Paradigm's broader thesis. So maybe it'd be helpful to understand how you see Noir's progress relative to that, and where maybe crypto infra and apps are heading with Noir, especially tying into that.
Totally. So what is Noir, right? So Noir is a programming language that, to me, is the Rust of ZK, and it empowers developers, similar to how Rust empowers developers to write efficient and secure systems code. I think that Noir empowers normal developers to write efficient and secure ZK code. 5 years ago, I was writing cryptographic circuits using the ArcWorks set of libraries. I think we've gone so far from that. And these days, we can write pretty powerful software. For example, the ZK passport work that I mentioned earlier, it's like only a few lines of Noir these days. Whereas if you wanted to do that a long time ago, that would have been probably many people, a lot of time. It would also be pretty slow. So the most important thing to me about Noir is the developer experience. And the developer experience comes downstream of a lot of the work that we've done at Paradigm. For example, the Foundry project, if you look, Noir has a similar software updater, the Noir Up or the BB Up software, which you use to manage the version of Noir. And I think that's just so important, being able to like one-click install the library. And then the second thing is, of course, the CLI and the tooling that goes around you writing a Noir smart contract, a program, or whatever you want to call it. So when you get these two things right, then comes into the experience of, okay, how do you further integrate it? And I think that what's going to be really exciting for Noir apps is the co-design of a Noir and a Solidity, or like an EVM, an SVM, or other kind of repository. So imagine that you have a monorepo where you write some of your circuits, but then you also have like some on-chain verification code that you want to run whenever some proof is generated against these circuits. I think that getting that developer experience done really well and having great feedback loop on iterating, I think that's going to be important. And then going a step further than that, I think that that's going to be the local flow. I think there's going to be a lot of work that people should do to figure out how to productionize these apps, which means, okay, I have my Noir program running. How can I deploy it on a chain? Is it like on Ethereum? Is it on Aztec natively? How do I get if I'm not deploying it on Aztec, testnet or mainnet natively, how do I set up provers for it? Is there room for a Vercel-like service, which does proof generation for others? Is there a Lambda-like API that you can do a serverless-like API, which like makes proof generation really easy? So I think there's like a big infrastructure blue ocean around proofs. And some people are doing proof marketplaces. Others, I think, we're going to do centralized things. I think, jury is out on what wins there. And finally, I think the most potent area for integration of Noir programs, I think, will be wallets, personally. Whether it is, again, for account recovery, privacy, credentials, all of that. So I think they've just touched a blue ocean of things that people haven't been doing for such a long time because the access to ZK was hard. And Noir democratizes or empowers like the average dev to do all of these in a way that I think is just new, and that's super exciting.
So you mentioned a few things, identity verification, selective disclosure, this broader blue ocean of infrastructure. What would you build today with Noir? What do you think is the most needed and maybe missing in the ecosystem that Noir and this fast client side proving that wasn't there 5 years ago needs?
I would turbo productionize methods for account recovery. I think that the most important thing that loses users today is that there is no equivalent of forgot your password button in wallets. I've been thinking a lot about wallets lately. We've been building a wallet library called Porto, and we want to integrate things like recovery of accounts assisted by ZK proofs, because it's so important to be able to give the user a forgot your password equivalent. And the way to think about it is that many people are moving to passkey wallets, which means that you can use your iPhone's biometric information and the iCloud sync feature to have access to your account across all devices. If you lose your device, you can recover access via the cloud. But many times people lose access to their cloud accounts. Maybe they want to log in to devices that they don't have access to their cloud account, like the list goes on. So you really need a super crisp way to add your account, to add a new account, to add a new signer to your existing account using some backup method. I think the backup framing is like cute, but it's not like it's not like expressed to the user in a way that's like safe and nice and cozy. So I think the framing around credential manager, credential, like the identity framing, I think is really important. So what I would do on Noir is like figure out the best way to integrate identity into wallets, and either integrate it as a service into a bunch of wallets or build my own wallet around that. And
Awesome.
the second part is like private payments, but I think there's like many ways to go about that. There's a lot of nuance. It's like really hard to get private payments right. Maybe you need like a full-on Aztec-like system to make it work. Versus, I think for the identity part is like pretty tangible for people that aren't, privacy gurus to make it work.
Yeah, the identity part, I really think ZK Passport and what they're building with Obsidian, their wallet on Aztec, is like kind of the first incarnation of that. But maybe building off of that, since Noir maybe makes writing circuits simple, even elegant, what would you say is the next major hurdle for deploying impactful ZK apps at scale for developers who are listening today? Is it like proving times, DA, tooling? What do you think is the main thing that these teams need to figure out?
Yeah, I think the first thing that you need to figure out always, well, all of these things that you just said, firstly, are important. So the three things that you said is A, production deployment for reliability. 2, performance, where it might be hosted or client side. 3, developer experience, security, all of that. So what we learned from building Foundry was that when you give people fast local testing, people start doing all sorts of crazy things that they weren't able to do before. So to me, being able to have the Foundry of Noir type experience where you can fuzz your circuits and be able to even differentially test your circuits against native generations. So let's say I have like a Python version of my code and a Noir version of my code, and I want to differentially test it to check that they always give the same thing. Because let's say I have like a good RSA library in Python, but I don't have like a great one. I know Zach has written a great one in Noir, but let's use that as an example. I think that's super important. So being able to fuzz and compare different implementations, because circuit compiler bugs are really nasty. And I think it's really important to be able to like convince yourself that the thing that you wrote is secure. So the first thing I would get really right is security and developer iteration speed, which means that the Noir compiler must be fast, the testing process must be extremely fast, the testing process must be extremely deep, the testing process must have debugging, fuzzing, tracing, the ability to see everything that's happening in a Noir program really deeply. Once you have that, that means that you've nailed the local development flow, which means that you can go deploy. And when it comes to deployment, you need to think about two things. Am I proving ultimately client side or server side? I think that depends on the use case. So most of when do you do client side proving? You do it when you want to preserve the user's privacy, right? Because if you do server side proving, it's very likely that you're going to leak a bunch of your information on the server. I know there's work to maybe make it such that there's like a little bit of local work that you do, and maybe you outsource the rest of the proving the server. I also think that might be a business on its own. So some kind of business where you generate the big meaty part of the proof server side, but like client side, there's like a light part that's done. Again, that's very similar to how the Aztec ZK approach works, where you do a private transaction locally, you client side prove it, and then the roll-up aggregator collects everything together, and that's a more expensive operation. For client-side proving for the wallet use case, I actually don't think that it needs to be super fast. Remco Bleman from WorldCoin one time told me like of this very clear UX pattern where you want your UX to be instant or loading bar or spinner. And there's like different ways to think about that. And I think for account recovery, the loading bar UX, where you leave your phone aside, you scan your passport, and you leave your phone on the side, you go prepare an orange juice, and then you come back and it's done. I think that's great. I think that's totally fine, because what the recovery is going to do, it's going to add a new passkey to your wallet, for example. But if the other way to think about it is, let's say you're in a coffee shop, and you want to make a payment, and you have a person behind you waiting, you surely cannot be waiting for the loading bar to complete, right? So that's like when I think of myself in the place of the user is kind of like in stress. They have other people behind them. They cannot really wait. They're not going to use your app again if like it's going to be slow because the person behind them gave them a traumatic experience. So what you want there is you want to either be spinner or instant UX. And that's where the client-side proving performance really matters. So what does that mean? It means that if you're doing some kind of like payments use case and you cannot delegate the expensive part to a server, then client-side proving performance is going to be super, super, super important. Now, what I know is that some people are experimenting with, maybe I can do a TE, like a server-side trusted execution environment that I can privately post them my public data. The server kind of learns about the data, but it's not very exposed to anyone observing the server. And the server generates a ZK proof about that data and forgets then whatever data I sent it. I think that is a very, very solid solution. I think Celo's self project might be doing something similar to that. So I think these are all very credible ways to go about it. And then when you think about the server-side deployments, I think that the biggest use case for server-side deployments of ZK are generally verifiable applications, some work that Sexing was doing recently, or ZK rollups. I think that's like also a blue ocean of things that we just don't know where it will go. People were very excited about machine learning in ZK. Obviously, that has like 3-4 orders of magnitude overhead. But who knows? Like maybe in a few years, maybe the overhead is going to be almost zero because some kind of like super pipeline thing works and you don't feel the ZK overhead. So I think there's like many things to get right. But the first thing I would get really right is like the security and the developer experience. And then 2, be really clear about the use case I'm targeting, because that informs a lot about, do I need to be fast client side? Maybe I don't need to be fast client side. If I need to be fast client side, where are my bottlenecks? Where do I optimize and so on? But I think that was going to be really hard, really important to figure out. And again, imagine a client side usually means mobile side. If you're doing mobile side improvements, that means that you need to take account all of the possible devices out there. What GPUs do they have access to? How much memory do they have access to? If they don't have access to much memory, many Fry-based ZK schemes are just Fry-based proof systems are just not that like convenient to use, and you need to do like smart things to limit memory usage. So there's like a lot of things to get done right when you get into client-side proving. Um, so maybe like server side, like with a TE, might be like a good option for like some people. So I think it's like just so early, and so many things to explore that whoever figures it out and like just runs with it, I think that could be really exciting for them.
Yeah, so all of these ways of thinking about these technical bottlenecks and this tie into UX, I'm especially interested in. So I'm curious. So what do you think is like the critical realization for these teams that are building in NoirHack now for their project to really get adoption? So it seems like a lot of the technical bottlenecks that you mentioned ultimately tie back to UX, and that's like a core principle. But if there's any core principles around adoption for these teams that are in these blue oceans or really trying to get actual users.
Yeah, well, I'll maybe push back on it. So let's use the TLS analogy, right? So TLS was not adopted early on because it was too slow. And even in my university, like when I was studying, which was not too long ago, our book, it was saying that, it was like written like maybe in the early 2000s, it was saying that you shouldn't use TLS to secure your connection because it's going to be too slow and your experience is going to be bad. And then TLS or SSL like got like fast enough, and people just defaulted to using that, right? And also, of course, like certificates became easier to give around, and people started adopting it. So I think there's like two things to get right. A, there's like really the performance. Like if the thing that you're building is slow, it's just not gonna get adopted. And two, it is that make the thing that you're building really easy to integrate. So if it takes a lot of like code to integrate, more than few lines, like Stripe's like motto was like 7 lines to like get a payment, right? Many people are saying, oh, 1 line import to like get drop-in replacement to get like blah, 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 blah. So if you don't make it really easy to integrate and make it obviously better than before, which means that the user gets access to something new that they really, really need. You know, if it's like nice to have, the user kind of, they just won't care, right? Because ZK to me, like as a technical person, means slower and more expensive, just because there's like more things going on. Verifiability does not come for free, and privacy does not come for free. So A, the value prop needs to be extra clear, and you as an app dev or a Noir dev must make as much work as possible to hide all that work, pipeline that work, make it happen in the background, showcase like fun things to the user. The user clicks something, immediately you dispatch the ZK proof generation, and the user still needs to do other things, such that while they're doing the other things, there's like a background proof being computed. So it's so important to get the integration right. And if you cannot make it fast enough, make the user busy with other things while the proof is being generated. Because no user wants to wait unless they're in this like account recovery thing where I said earlier, where the user, the user is trying to get back in their account. And that is likely faster than them calling support or them, doing forgot your password over like a multi-factor authentication flow.
I really like the analogy of TLS, and especially with TLS progressing and becoming faster. If ZK proving became 10 times, let's say 100 times faster, what new possibilities open up for you that excite you, and what would you build or see people building then?
Yeah, I'm not sure that 100 times faster is enough, right? To make it like available to everyone, because I think realistically, the world where like ZK just becomes like invisible. Justin Drake had talked about this a long time. Was like, let's say you have a chip, it's like that's like say 100 nanometer chip, and like 1 nanometer of that chip is like the native compute, and the 99 nanometers of it is like the ZK part of it. And anytime you do a step in the 1 nanometer processor, that triggers a ZK proof in the 100x like die overhead of it. And that way, maybe you can get to something that looks like a real-time proof that gets calculated in a per CPU step, which is like a true, like actually verifiable, like real-time verifiable app. I think that's going to be super exciting. I think that's like super far away. I think if we do go like 2 orders of magnitude away, like I think basically private payments and ZK identity stuff become like just default, which I think is super exciting. I don't think we get, private machine learning, verifiable machine learning, like, at scale, like, to be trivial cost. That might require the thing I said earlier. But the very least, with like 2 orders of magnitude, I do think, that we get like, few like sub millisecond private payment, sub-millisecond attestations to any credential. I'm sure everyone on the NoirHack hackathon saw Google adding the proofs from ECDSA paperwork in the Google Wallet. I think that stuff is just going to get everywhere. Apple is going to integrate it, like Google is going to integrate it. It's going to be in every device. So yeah, I think it means like ubiquitous access to ZK for applications and identity or attestations, which I think is super exciting. I know that people talk a lot also about like attestations to like TLS connections. I think these are like a bit trickier to get right because they involve usually, I think fundamentally they involve a trusted third party, which is either a proxy or an MPC network or some kind of like weird mechanism or a TEE or something. And I think these are kind of like, you know, the ZK stuff that we're talking about does not involve a trusted third party, whether it is one, many, decentralized, centralized, whatever you want to call it. So I'm not talking about these specifically because I think the threat model in these, it kind of devolves into a non-colluding party assumption, which if you can do that, you might as well, I think, do like a TE-based approach.
And I have one last question for you. I think you're well known for going into some very interesting, like technical or conceptual rabbit holes. I'm curious what you're exploring now and how Noir might potentially play a role there and any other places that you have explored more recently or just in general.
Yeah, so to me, the hardest, so when I'm thinking about how do I add ZK to a JavaScript app, I think the thing that nobody has looked into is like, how do I make the bundle size really small? So, you know, when you're building a web app, like the web app loads and it needs to like call a bunch of JavaScript. If like I'm loading a big WASM blob to make that work or whatever, right? So I might be saying something wrong on a deep level here. If you're loading a bunch of data and that takes a while and makes the page load slower, again, nobody's going to use it. So there's like some nuances around how do you really architect that really smartly to either like there's some like Noir engineering magic that you can do to, you know, pull the WASM files or like whatever else like in pipeline ways such that the user doesn't feel it, or there's like some real ways to make that really small. I think that's like one super interesting rabbit hole from the user side. And then, you know, there's all sorts of like cryptography things that you might want to do, like, you know, better recursion mechanisms, like much more flexible ways, you know, to, let's say there's like a low power device there's a low power device where they have like lower memory or lower GPU. Can I do like some kind of like web GPU deployment that is like very flexible and can detect what device it's on and accelerate accordingly? Browser support. I think that all of the hardest problems are kind of like closer to the user, and basically I have like full trust in our cryptography expertise on the lower level stuff, right? So I'm kind of like past the stage where I worry about getting the cryptography stuff right. Maybe there are some errors along the path, but I think like people are gonna figure that out. The things that really concern me right now and are really interesting rabbit holes is like the packaging, like how do you make that like really, really simple to the user? Rabbit holes that I find very exciting, post-quantum cryptography always, depending on who you ask, I think that's like super interesting. Accelerating of like non-native field arithmetic, I think is like extremely important. I know like Zach has done a bunch of work on that. I know people have like opinions on how that should work. I don't know enough about that topic anymore. Hardware acceleration of ZK proofs is like one of the most exciting things for me, whether it is with specialized hardware or making work on existing things. Yeah, I think these are just some of the things. Oh, and finally, of course, like the security component, where you know, until we have like a good way to know that like is this program constrained appropriately or not, I think like that is like probably like one thing that like really needs to go well, right? Because I've done like security of circuits like many years ago again on ArcWorks, and it wasn't beautiful. It required like a lot of like, you know, getting deep into nitty gritty things. And you know, a compiler bug in Viper a few years ago could have costed like millions of dollars. The worst thing is like in ZK, if you're doing private payments, especially, there might be bugs around infinite mints that you cannot detect and so on. So these are like, you know, these are the real problems that I have no conceptual understanding of how to approach.
Mm. Yeah, this is a good portrait of some of these areas. I think like what you had said about blue oceans. Maybe one last question. Also, want to be understanding your time. But yeah, do you have some time still, or
So I say that again.
are you okay on time?
Yeah.
Okay, cool. I guess I would love for you to expand a bit more into some of the blue oceans that you had mentioned. If there's maybe some hierarchy or some areas that, like, if you were to start today in the space, just literally building, which one you would preference and prioritize?
Yeah. Well, again, I think that crypto first and foremost like does transfer of value. I think like one very exciting thing is like figuring out like a wallet where its entire policy engine is like a snark, and the rules are completely verifiable by a program hash. I think that's just so interesting as a blue ocean. um, I think anything again, I don't know. Like I'm a simple man. If I can like get like my identity in a way that I can like make claims about it, and I can bring other real world like credentials on the system, and then I can also make payments or called smart contracts. I think that's just such an exciting bundle. Um, and people might want to nerd snipe you with like things that are like super far out, but like this stuff like has so much meat like to explore. That yeah, I think that honestly, my honest take is that like people should just focus on these things, get them really right, because crypto needs this to get to the next level, right? If you go to, I don't know if you're a Dymo user, if you go to Dymo or like in the Dymo app, and if you go to Dune has a Dymo dashboard, and I can go and like type Georgios in it, and I can see all of my transfers. That means anyone can do it. There's no world where crypto grows. We can do global scale crypto without that. So I think that's, people should really focus on getting that part right. And we can talk about, super crazy, ZK things like down the line. Obviously, there's institutional levels that you can do, institutional level things that you can do with dark pools. You can do like fun games. So last year, in our conference Frontiers, we did a very cool demo with the Cursive team where we did kind of like a privacy preserving, not a dating app, but like a recruitment system where let's say I'm a recruiter and you're a person that is looking for a job, but you don't want your employer to know that you're looking for a job. You would configure in your profile locally your settings, and I locally would have like my settings configured on I'm looking for people with such and such profile. We would meet, we would tap our badges to each other's phones, and would do private set intersection on these and figure out, hey, is there a match between these? And then you, the candidate, could say, oh, I opt in to revealing to the recruiter that I want to be recruited, which is a good way of thinking of how ZK facilitates safety beyond just financial safety. I think that applies to like any kind of like information that you want to share with someone where you might be too embarrassed to share, or you might feel unsafe about sharing. So you can imagine all sorts of like social games that you can create around that, or literally coordination techniques that are, you can hide information about like really important things like public places, and only the people that you have opted in can find that information. So that's all sorts of like interesting things that you can do with that.
There's a cool app that was built in the hackathon that is a dating app with MPC where you can share like certain private things that you like
Right.
with others. It's kind of in the same way. Maybe one last question, actually, maybe actually last question. But I was curious, since you mentioned like this kind of potential areas that people don't focus on enough. Maybe there's areas that people focus on too much and get trapped in. Like I think YC has this term, tar pit ideas. Maybe are there any like tar pit ideas or areas that you see a lot of people focus too heavily on in ZK or with Noir, and what those might be and how teams can avoid being stuck in that? Maybe they're too technical, complex, or yeah.
So you heard me only talk about apps, right? I wish that people focus on apps, and I'm glad we went through the roll up phase. I feel like the roll up tech is like really mature personally. So I don't want, like, I think we should polish the existing stuff a lot. but I think we have figured out like the right abstractions and all the ways to approach it. Whereas I feel like, like spending time on the marginal roll up improvement, like on a new stack or something, I would be sad like to work on it personally. I think that the Aztec like stack is like, killer because it's like built from the ground up for that. But if you were to do like another like standard validity rollup, I don't think that's like as interesting. I think it could be interesting if you were to pair it with like, let's say, a perp dex, where liquidations are verifiable, or you can have like some kind of like very extreme rules about it. So let's say you did a perp dex where liquidations are private and verifiable, or people's balances are not private. Some things around that, I think they're like pretty interesting. Yeah, so like that's another app that I would invite people to build, actually, some kind of like dex that has that allows liquidations in a privacy preserving way. I don't know how tractable that is, but yeah, if you're just building a validity rollup on Noir or on anything else, like without any like real privacy innovation beyond the stuff that we've talked about, I think I wish people spend more time on other areas.
So I guess the principle there, like with the perp dex, is that it solves like an actual problem.
Yeah.
Through like yeah, exactly.
Yeah, but again, like
Cool.
if somebody's working on that, don't let me deter you. I'd still, I'd still talk to that person.
Cool. Well, awesome. Thank you, Georgios. I'll stop the recording here.